One of the nice things about calculus is that there's plenty of ways that we can apply it to answer real-world problems. One such way is kind of deriving this thing we call the rule of 70, which helps us approximate how long it takes an investment to double in value. So we're going to ask the question, suppose I invest some amount of money, we'll call it P0, compounded annually at an interest rate of R%. How long does it take my investment to double? So what you might know, or you might not know, is that given an initial investment of P0 and an interest rate of R, the amount of money you have, P of t, after t years is given by the initial amount times 1 plus your interest rate. Since it's a percent, we're going to divide by 100 to the power of t. So we want to know how long or when does this amount of money that we have, when does that equal twice our initial value? We can divide both sides by P0 and get when does 1 plus R over 100 to the power of t equal 2. And just to simplify a little bit further, we can take the natural log of both sides. When we do, we're allowed to take this t exponent and bring it out front. So when is t times the natural log of 1 plus R over 100? When is that equal to 2? Or natural log of 2. This is the question we're going to be interested in. Now we could solve this, but it's going to involve a lot of math. And we want to come up with a rule that's relatively easy to do on the fly. So to do that, what we're going to do is we're going to approximate specifically the natural log of 1 plus R over 100 using a linearization. Because if we can write that a little bit simpler, it's much easier to solve linear equations than it is to solve equations with natural log. So if we can rewrite that using linearization, that would be really nice. So what do we know? Well, we have a function. My function is going to be natural log f of x equals natural log of 1 plus x. And we're plugging in we're interested in f of R over 100. And that's a pretty small number, so we're going to linearize at 0. So let's go ahead and do our linearization. We'll have L of x equals f prime of 0 times x minus 0 plus f of 0. So now we need to find what's f of 0 and what's f prime of 0. So we have f of x equals natural log of 1 plus x. F of 0 is going to be natural log of 1, which is 0. F prime of x, we need to use a little bit of chain rule here. It's not too bad. So it's going to end up being a derivative of 1 over 1 plus x. Think of it as taking the derivative of the outside, keeping the inside the same, multiplying by the derivative of the inside, but the derivative of the inside is just 1. And if we evaluate f prime of 0, we're going to get 1 over 1 plus 0, which just equals 1. So my linearization is going to end up being L of x equals f prime of 0, that's just 1 times x minus 0 plus 0, or L of x just equals x. So what we see is that natural log of 1 plus x is approximately x when x is about 0, is close to 0. So natural log of 1 plus R over 100 is going to be approximately r over 100. So let's go ahead and use that here to see if we can figure out what this t-value is going to be. So now we have that t times natural log of 1 plus r over 100 is about the same as t times r over 100. So we can write our equation as we're looking for a t r over 100 equals natural log of 2. Remember, we're solving for t, so we're going to multiply by 100 over r on both sides. When we do, we're going to get that t equals natural log of 2 times 100 over r, which is about 69 or so, 69 and change over r. And what we see, we call this the rule of 70, so we might as well just make that as 70 for the sake of, simplicity. And what that tells us is that, in conclusion, it takes about 70 over r years for our principal value, or our principal investment, to double. And that's exactly what the rule of 70 says, is if you have the interest rate and you're interested in how long it takes to double, you don't necessarily need to solve this complicated equation here. You just need to do 70 divided by your interest rate, and you'll get something that's in the ballpark of the doubling time for your investment. So there you go. There is a relatively easy way to calculate how long it takes an investment to double, and we did that using linearization of functions, which is a calculus skill.